Hello, geometry. So today we're going to be looking at section 4.3, which is proving that lines are parallel. So we've had our rules so far where we assumed the lines were parallel and then we said something about the angles. And we had these in if-then statements, which said if line L and M are parallel, then angles 4 and 6 are congruent. Then the alternating interior angles are congruent. Today we're going to be talking about the converses. And all the converses mean is that we don't start with the assumption that the lines are parallel. We're going to start with the assumption that the angles are congruent, or whatever the relationship is, and prove the lines are parallel. So we're reversing it. Instead of the lines are parallel, so the angles are this, it's the angles are this, so the lines are parallel. That's all a converse is flipping which part you start with, what the assumption part is. So let's jump down to example 1. So here we have all these converses. So if we have two lines cut by a transversal, that's just setting up our diagram. So that a pair of same side interior angles are supplementary. So that's the part we're assuming. If the pair of same side interior angles are supplementary, then the lines are parallel. So if these two angles add to 180, the lines are parallel. Converse of the alternate interior says if the alternate interior angles are congruent, have the same measure, then the lines are parallel. And converse of corresponding angles, these two here, if the corresponding angles are congruent, then the lines are parallel. So again, we're starting with knowledge about the angles and using that to prove the lines are parallel in our converses. So let's jump into an example.
Alexander,
Sorry about that, had an announcement. So a mosaic designer is using quadrilateral shaped colored tiles. So we've got this tile. They're going to build an ornamental design out of these tiles. So we want to show, and all sorts of interruptions today. And there's a line there, it's a little hard to see in the black and white, but that's two tiles. So we're going to put them up one after the other like this. And we have our angles up here. We want to show that those two lines are parallel, that line 1 and line 2 are parallel. So let's take a look. With these two angles, we know that angle 1 is 120 degrees because of our sample tile, and that angle 2 is 60 degrees, again because of our sample tile. So we have our transversal here and our two lines. Because 120 plus 60 equals 180, which that makes angle 1 and angle 2 supplementary. So supplementary angles, if they're same side interior, make the lines parallel. So by showing that those two angles are supplementary, we've proven the two lines are parallel. Let's try another one. This time we're going to set those same tiles up, but in this configuration. So let's take a look. Angle 1, based on our sample tile, is 120 degrees, and angle 2, again based on our sample tile, is 120 degrees. What type of angles are those? They're corresponding angles. So what can we say about corresponding angles? If they're congruent, which in this case they are, we can say that our lines are parallel. So that line 1 is parallel to line 2 by the converse, because we're starting with the angles. Converse just means like reversed or opposite. Converse of the corresponding angles theorem. That's it. So you're just saying, do I know the lines are parallel? Yes, because the angles have this relationship. All right, let's scroll down here. We're going to skipping example 2 because that's going to need compasses. We'll do that in class. We're going to jump to example 3. Using the pairs angle pair relationships to verify the lines are parallel. So if we look at A, it's saying 3 and 5 are congruent. Are the lines parallel? Well, 3 and 5 are alternate interior angles, and our converse of alternate interior angles theorem says if alternate interior angles are congruent, then the lines are parallel. So yes, these lines are parallel. If we look at B, angle 4 and angle 8 are the two we're talking about. So they're corresponding angles, which means they would need to be congruent in order for the lines to be parallel. So let's see. This time they gave us formulas. X plus 20 for angle 4, 2x plus 5 for angle 5 or for angle 8, but they told us what x equals. It equals 18. So let's plug it in. 15 plus 20 is 35, so angle 4 is 35 degrees. And for angle 8, we're plugging in a 15. 2 times 15 is 30, plus 5 is 35 degrees. So those angles have the same measure. They're corresponding angles, and they are congruent. So yes, by the converse, yes, the lines are parallel. By the converse of the corresponding angles theorem. All right, that's it. So if I were to fill in this so sentence, it would say that angle 4 and angle 5 are corresponding angles. All right, that is it for today. I'll see you in class. Have a good one.